Welcome to everyone. We are here today for our webinar related to product design. Today we have the pleasure of have our speaker, and I will just present them after the outline of today. We have the presentation are related to the challenges of the implementation of industrial symbiosis, the role of awareness and education. Later on, we will move for industrial symbiosis in product design, bringing research with real-world case studies. Later on, we will move for circular economy, basic concepts and example, and we will finalize with industrial symbiosis footwear. Each presentation will have a duration of around 10 minutes, and after that, I will tell to you to summarize in case that you need more time. And as all of the attendants could see, there is a question box just in the right side below. So in case that you want to ask any question for one of the four speakers, just put there, and at the end of the session of today, we will solve all of the questions. But before starting, I would like to make a kind of short introduction of each of our speakers. We will start with Yasmin Karabulut, that she is project manager and SME consultant at the Erzurum Chamber of Commerce and Industry in Turkey. She's specialized in the SME's transition toward the twin and green transformation, and also focusing on internationalization, project development, and also strategic. She is pursuing her PhD on circular economy as well, and she's also trying to enhance awareness about all these kind of circular and green topics. Later on, we will move for Carlo Giglio. His PhD teaches innovation management and entrepreneurship in Italy, concretely at the University of Calabria, but also he's also professor at the University of Sao Paulo and also in a university in China. He conducted research visiting period in different organizations like the College Business School in UK, the DTU University in Denmark, etc. She is an evaluator and principal investigator at national, European, and international projects, and she also it's acted as European Commission European Technology Platform participant. So also he has a lot of experience in editing journals and working in different high important journals like hospitality management. Then we will move for Snezana Kirin. She's full professor at the Innovation Center at the Faculty of Mechanical Engineering in Belgrade, but also she worked on the University of Economic Academy. She is a bachelor degree in mathematics with later on a master degree in industrial management and engineering. She is PhD in risk management, and she had so much experience also in publishing paper, more than 70 papers, indexes in Scopus, and she has participated in several international research and development projects. Later on, we will move for our last speaker, Maria Jose Pinto Ferreira. She's director of the Quality Control Lab and Research Sustainability Department at the Portuguese Footwear Technological and Research Center. She holds a degree in chemistry, later on a master in environmental science, and also a PhD in environmental engineering. She worked in the preparation, coordination, and later on implementation of projects almost related to the footwear. She tests physical and chemical testing, like for leather, plastic, rubber, etc. And she's also focused on safety and environment. So also she has coordinated more than 60 projects. So after that, I don't want to take more the floor, and I will ask to Yasmin to present now. So as I mentioned, around 10 minutes, so the floor is yours, Yasmin. Thank you.
Thanks. I'm really sorry, but I'm at work right now and need to keep my camera off. Sorry. Hi, everyone. I'm very happy to be here and to
Sorry, Yasmin, could you do full screen, please?
Okay. I can't.
You were in the, it's just below the Cosaction logo.
Down, I see down the,
Down down.
yes, down right.
Yeah, it is right in Notlar and
Down and right, please, in the corner, before,
Oh, sorry.
could you share again, please?
Sorry. Okay.
Yasmin, could you share your screen, please?
Sorry. Oh. Yes.
You had to do here.
Can you see?
Here. Push this button.
yes, this.
Okay.
Thank you. Sorry.
Again, hi everyone. I'm very happy to be here and to be discussing this important topic with you today. Before I begin my presentation, I would like to briefly in my presentation I share why this topic matters to me. I'm PhD at Atılım University and my research mainly focus on international digital transformation, circular economy, green transition. In addition, I have been working as an SME consultant and project manager at Erzurum Chamber of Commerce in industry for almost 10 years. During this time, I have been involved in many projects and provided consultancy services on national and international collaborates and growth strategies and technology renewal and infrastructure investment. And in recent years, with increased government support for green transformation, SMEs have significantly increased their investment in this area. Working directly with SMEs has allowed me to gain rich and diverse experience in this transformation process. So why did I choose this topic? Because I believe my field experiences and real life examples can add new insights to the existing academic literature. I will now move on to my presentation. Okay. First of all, I would like to start by answering the question, what is the industrial symbiosis and what is it not? First of all, not along just recycling and simple waste manager, a strategic business model and involves collaboration between firms in Turkey, important. Focus on the mutual economic and environmental gain. What is industrial symbiosis? Industrial symbiosis, in other words, systems where companies collaborate to turn one's waste outputs and other its inputs, so clearing mutual environmental and economic value. Sorry. Okay. Various implementation, technical or technical. Let me briefly highlight a point that is frequently emphasized in the literature. Technical barriers lack of suitable structure, many industrial areas are not physically contacted. Our equipment to enable research exchange, limited access, especially in small and medium-sized SMEs, outdated technologies. Many firms are unfirm that are already engaged in symbiotic practices or do not know the potential benefits, in my opinion. And trust confidently, companies may hesitate to share operational data or cooperation due to fear of competition or loss of the control. Trust and confidently, weak, inconsistent or unclear regulations and lack of supportive policies can hinder collaborate projects. And in my option, finally, without dedicated mediators or platforms, firms may struggle to identify potential patterns and communicate effectively. Maybe. Studies industrial symbiosis. As we said that in both literature and in the field, these barriers are not related to in structure or financially, but many of them directly linked to how to how we think, how we perceive, how we organize cooperation, and what we know. Based on my experiences in the field, I can easily say that lack of awareness, especially among SMEs, SMEs is one of the most critical obstacles. In Turkey, industrial symbiosis is rarely addressed in independent is topic. It's generally seen as a part of green transformation, a circular economy, or green industry. Even government findings programs do not name it directly, which limits awareness and feasibility. In my own consultant experiences, I often observe that SMEs already apply in luggage of industrial symbiosis, but they don't know what to call it. By the way, in Turkey, there are 7 regions based on socio-economic levels, development levels, and we had the opportunity to work with SMEs in the almost of all these regions as a consultant, generally in Turkey. Therefore, I can easily say that this issue not specific to region. It is a pattern and that can be observed across of Turkey. In my opinion, because there has been almost no awareness raising study in which industrial symbiosis has been introduced to the masses with its name and basic approach. Likewise, if I had not been involved in this action, perhaps I would not have gained such awareness or learned so much despite being a counselor. Sorry. I would like to briefly share a recent experiences with you, if that's okay. Not long ago, I fortunate company contacted as for project consultancy with a scope of a national green industrial transformation support program, cost gap, in Turkey. Their intention was to develop a project focused on energy efficiency. However, as we start repairing the project, we realized that this investment should go beyond energy efficiency and be based on an industrial symbiosis-driven business model. When I explained industrial symbiosis to the company concerned, they said that they hear this term for the first time, but they also state that they had been practicing it for years without knowing it is basic principles. The company explained the step it has taken to manage its waste more consciously, reduce losses, and transform its outputs into its inputs for another firms. They said that they have been given the wood sawdust generated after the production process to pallet procedures for years. After learning more about the topic, they realizing the potential they dedicate to invest directly in this area. To support this transition, we have added the machinery to the project, including steel silos for storage and solid waste crusher and grinder to increase clean production and environmental sustainability. The project was approved with a budget of approximately 4,500,000 Turkish liras. And to be honest, this is just a last example that put it into my head today. We see that concept of industrial symbiosis unfortunately still not fully know or not sufficiently understood and implemented.
Sorry, Yasmin, 1 more minute, please. You are out of time.
Yes, please.
Sorry, I don't understand you.
5 minutes.
No, only 1 minute more.
Moving on, speak.
Please conclude your presentation, please.
Have you seen?
Yeah, we are seeing your screen, but what I'm telling to you is that you are out of time, so I kindly ask you to just make your conclusion in 1 minute, please.
1 minute. Oh. Okay. Finally. Yes. Sorry. Sorry.
Jasmine, have you finished, please? She has some internet problem because he's out. So, okay, let's move for the next one, please. I will give the floor to Carlo, please. He's going to present the industrial symbiosis in product design. He's going to bring us some real world case studies. So please, Carlo, if you could share your screen.
Hi, everyone. Good morning. Can you see my presentation?
Yeah, if you could do full screen, please.
Okay, perfect. Thank you very much for the invitation, for the opportunity to be here. And I'm going to present, as you already mentioned, research that is aimed at bridging research trends and gaps related also to real-world case studies from some companies applying some industrial symbiosis within the field of product design. So what I'm going to present today is related first on the application of industrial symbiosis in product design. One of the key points here is the fact that when talking about industrial symbiosis in product design, there is a focus on the value of the design inputs and in particular to some features during the new product development, and so to the inception phase of new product development that is related to design that are linked to the features of modularity, repairability, and recyclability. This is even more important in other contexts related to industrial symbiosis, also because product design has some relevant impacts when industrial symbiosis is embedded within it, that is making it possible to achieve around 80% of environmental impact that is already determined at this design stage of new product development, and also 30 to 70% of waste reduction, and also 20 to 40% of cost reduction in terms of materials. And with that research related to the literature review that I conducted so far is reveals as key branches of the research trends nowadays. In fact, what we can summarize is the fact that data symbiosis in product design is important because of the inception phase that make it possible to embed product design within industrial symbiosis practices, also the paradigmatic shift of production, and also the impact that this can have on regional development. What I conducted is literature research that make it possible to identify 31 studies that are related to industrial symbiosis in product design according to some criteria that have been reported here with the Prisma methodology for systematic literature review that we conducted. What I discovered is that there is an increasing productivity in the research field related to industrial symbiosis on product design, but also there is a lack of collaboration with a plot that on the right side demonstrates that maximum two authors usually collaborate in research works related to this specific field of industrial symbiosis. Also, we find that among the most productive countries, we have United States and Italy, with Italy leading in the world, but that is not appearing in the collaboration network that we see at the bottom of this slide, because Italian researchers are mainly working alone, not collaborating with researchers from other countries. So losing the perspective of how industrial symbiosis is applied in product design processes in other contexts, in other countries where other industries can be more relevant compared to the industrial context of Italy. And this is also proven by the most cited chart here. Probably this is due to an exogenous bias in research that is biased by the current regulatory evaluation evaluation system of universities on research production related to the publisher parish paradigm. Anyway, what comes out from the global literature review analysis is that there are several branches of research in industrial symbiosis on product design that are related to industrial ecology branches or byproduct reuse and the concept of the application of life cycle assessment on the other side. And then another more specific and focalized research on research lines related to Industry 4.0 or 5.0 and also the microalgae. And another one, again, is also related to the manufacturing or also to the composite materials. So we have potentially 5-6 different branches of research that are specializing the research landscape globally on industrial symbiosis in product design with different stages of maturity, as you can see from this world map. And also there is a fragmentation of categories of keywords, as you can see on the last column, that is the categorization according to a keyword plus algorithm in order to demonstrate how the authors from keywords can be regrouped. Anyway, the word frequency over time does not clarify in itself what we have seen with the word map. But if we go further and further in the bibliometric data analysis, we can identify some thematics that can be considered like the motor teams that are now driving and will drive the current research trend in terms of relevance and also in terms of density and level of maturity and development of the research. That are the ones that we indeed mentioned in the word map before. That is composite materials and design for the manufacturing on the one side, then circular economy and industry 4.0 applications on the other side, and finally also industrial symbiosis with the byproduct reuse. Now, what are instead things that are happening in industry? Making some case studies in order to have a view of the trends from the industry. Well, there are some cases that have received some funding from industrial symbiosis grants in the United States, for instance. So out of the European context we work mainly within in the cost section that are the Cascadia Produce that created a retail rejection hub and distribution center for the rescued food by using also an online platform, a real marketplace that also gives the possibility of delivery of quantities of rescued products to the organization that are aimed to use them. What is here is the designing of logistics for rejected food by using also an online digital platform, marketplace. And instead, what is the component related to the product design is the fact that digital platforms are used for real-time waste-to-resource matching. So these algorithms for matching are now embedded within the product design phase. The second case regards Qualterra, also in the United States, that is trying to turn downstream material into useful biochar products to bolster the crop and soil health, trying to also create the basis for recycling biomass waste and also make it possible for farmers to create profitable and environmentally sustainable solutions. Also by using the waste, the industrial waste, for generating as a byproduct some renewable energy. Here, the key in the symbiosis practice practices related to the transformation of biomass for salt, but also into a byproduct that is able to generate renewable energy. And on the other side, the product design is related to the closed loop system that requires cross-industry R&D partnership to be created, to be implemented. And the third case is instead the Future City Co case related to the use of data analysis in order and algorithms to forecast the input-output balance for each of the manufacturing activities in a specific area and in a specific industrial zone, and triangulating a range of data sources in order to optimize the algorithm and match all the data to outline the optimal geographical clustering and distribution of the factories in order to facilitate industrial symbiosis practices, like simulating 600 more or less resource flows in order to triangulate all this data and optimize the factory clustering. And on the other side, the design aspect is related instead to the proximity, geographical proximity, and the digital twins that are critical for industrial symbiosis scalability. To conclude, there are four main future research directions to be followed in order to bridge research with real-world applications that are related to the integration of artificial intelligence and blockchain integration, machine learning, like in the cases one from Cascadia Produce or Future City Co, and also also for the resource exchange automation systems. In the same cases, Cascadia Produce and Future City Co. Then instead, the policy development and regulatory hurdles and standardization issues that are related to the cases of Cascadia Produce and also Qualterra. And finally, because education is as the basis of everything, the education integration and the university industry partnership that has shown to be disconnected between the two worlds, according to this literature review and the real case studies, with design initiatives for design curriculum standardization, metrics, supply chain management research involving university with algorithms together with the industry in all of the three cases. So thank you very much for your attention. I hope I have stayed within the 10 minutes more or less. Thank you very much.
Thank you so much, Carlos, for your presentation. Quite interesting, the three case studies, something to think more about. I will now move for the next speakers. It will be Snezana. She's going to explain circular economy, basic concepts and examples. So please, the floor is yours.
Good morning, everyone, once more. Can you see my presentation?
Yes.
Okay. My presentation focuses on the basic principles of the circular economy. We will begin with the issues of sustainability and the projection that global material consumption will double between 2017 and 2060. Oh, sorry, what I did, because and the rate of waste generation is increasing faster than the rate of urbanization today. And there are principles of circular economy listed here. The first one is that nothing is waste. The second is biomaterials are renewable and they should be used as input materials whenever it is possible. And non-renewable materials must be recovered. These materials should be reused or recycled whenever feasible. Can you hear me? Hello?
Yes, I can hear.
Oh, sorry, I thought that something is wrong. And products should be reused. If reuse isn't possible, attempt to salvage parts, increase the use of renewable energy, and ensure inputs come from the nearest appropriate supplier. And here you can see measures to reduce waste. That these are source reduction, reuse, recycling and waste separation, organic waste usage, regulatory measures, education and awareness raising. We heard already about that, and innovation and technology. You can see detailed description of the listed measures. And there are also growing concern regarding resource availability. And we can see here that fish stock are decreasing, also biodiversity. We have problem with ocean degradation, global carbon footprint, deforestation, land degradation, loss of arable land, and a million people feel lack access to safe drinking water, and it is increasing demand for critical minerals and metals. Definition of circular economy could be that it is an economic model focused on the prolonged use of resources, waste reduction, minimizing negative environmental impact through improved efficiency and sustainability. There are here listed 5 types of circular business models. You can see that first one is circular supply models, the second is resource recovery models, the third sharing economy models, product life extension models, and the last product service system models. The first one is circular supply models, which refer to business models where the focus is on sourcing renewable or recycled materials rather than using virgin resources. Key principles of these models are designed for reuse. Products are designed in a way that components can be easily disassembled, extending product lifespan through repairs, refurbishment, and redesign, use of secondary materials, closing material loops, and digitalization and resource tracking. For example, IKEA is one of good examples because their modular furniture can be easily disassembled for reuse or recycling. And also brands like Patagonia are known for using recycled polyester from all materials and make in their production. Challenges are initial investments because it requires significant investment in technology, infrastructure, and system redesign. So also supply chain cooperation can be complex and difficult to achieve, and cultural change which require educating employees, consumers, and suppliers about the benefits and logistic of circular models. The second listed models is resource recovery, and we have here 4 subgroups. The first one is downcycling, which is a recycling process where materials are reused, but their original value or quality is reduced. The second is the process of recycling, which is process of reusing waste to create new products of the same or similar value as the original. Upcycling involves creating higher value products from waste materials, and the industrial symbiosis, and Yasmin and Carlo have already spoken about that. Here is examples. Here you can see several examples of downcyclings, that recycled paper is used to make toilet papers, but due to the loss of fibers, the quality and durability are lower. And construction waste is recycled into material for foundations or structured, but it is not suitable for making high quality concrete. And all cotton are recycled into materials for insulation or cleaning clothes, but they can't regain their original quality. Recycling we mentioned already, and here you can see that glass can be endlessly recycled without loss of quality, and aluminium also is highly efficient for recycling. Upcycling is the process of converting waste into products of higher value than the original, and you can see here several examples that old jeans, for example, of fabric scraps can be transformed into modern bags, furniture, or unique fashion pieces, and leftover fruit and vegetable scraps are turned into high quality compost for plant cultivation. Furniture from pallets, you can see here the picture, and glass bottles can be transformed into lamps, candle holders, or decorative items. Here we have characteristics that creative and innovative use of waste material, which adds aesthetics or functional value to materials. And here is table with comparison of 3 types of recycling, downcycling, and upcycling according to characteristic: material quality, energy consumption, waste reduction, material reusability, environmental impact, economic impact, and end-of-life products. Industrial symbiosis, I think that you talked about that I will skip. Here is just example for that plant in Kalundborg in Denmark. Use power plant produce significant amount of waste heat. Instead of this heat being wasted, it is used to warm nearby homes and industrial processes. Waste water from one factory is utilized in the cooling process of another. Ash products by the power plant is used as a raw material in the production of cement. There are also some more examples of industrial symbiosis. Maybe it is interesting that fruit juices often leave behind pulp, peel, seed, other byproducts that are rich in antioxidants, vitamins, natural oils, and they can be repurposed as ingredients in cosmetics. And in packaging also can be used fruit or products. Sharing economy models are the next type, and their characteristics are that efficient resource use, reduced consumption and waste, increased accessibility and flexibility. According to statistics in Europe, cars spend 92% of their time parked, and when they are used, they transport an average only 1.5 people in a 5-seat vehicle. Also, statistics said that average productive time of a drill over its entire lifespan is only 12-13 minutes. So it is useful to share them temporary using digital platform. There are also possibility to renting clothes. Here are some examples of sharing models, and you can see here several machine sharing platforms, sharing models in symbiotic industry, and there are new opportunity for these models. Characteristics of this model of sharing models are that digital platforms play a crucial role in...
Sorry, Snezana, one more minute, please, for concluding.
Okay. And here are product lifespan extension models. You can see several listed examples that products that last longer at a higher price, offering used products for return and resale, providing maintenance, and offering refurbishment. And here are models and examples and models of product service system that could be product-oriented, use-oriented models, and result-oriented models, and their characteristics are listed. And here is given strategy, 9R strategy in 3 groups. First is smarter production and use of products. The second, extending the lifespan of products or its parts, and efficient use of materials. And their barriers to transition to this economy are listed. And for example, for the conclusion, circular economy offers extremely high growth opportunity through innovation, collaboration, and adaptation to market changes. And key success factors include innovation, innovative design, investment in high potential sectors, support from governments and institutions, increasing consumer awareness, and collaboration between large companies and SME. Thank you.
Thank you so much, Snezana, for your presentation. Also for the audience, you could see that some of them go pass through the slide. Don't worry, because we are going to share with you the contact detail and also the full presentation, so you will have time to read everything carefully after the session. So thank you again, and now we'll give the floor to our last but not least speaker, Maria Jose Ferreira. The floor is yours.
Hello, good morning to all of you. Thank you for participating, and thank you, Almudena, for the invitation. I don't know if you are seeing the presentation very well, but I hope so. Okay, yes. So I will talk about industrial symbiosis at the footwear industry cluster. Beginning with a very small introduction to what is a footwear cluster, then what we believe is the footwear of the future, and finally very short introduction to CTCP. Regarding the footwear cluster, in the world and in Portugal, I would like to highlight in green, in this graph you see, the growth of footwear production, and in gray, the growth of the population. And you see, we could imagine that 3 pairs per person are not too much consumption. But in fact, what is happening is that in Europe and North America, we consume above 6 pairs per person annually. So we are really consuming a lot of resources from our planet. Another point is where is footwear produced? What is the sustainability of this class overall? You see the black numbers, the dark ones, were the production in percentage in the world in 85, last century 85. And nowadays we have the data in green. So you see that Europe passed from over 30% to 3%, and Asia grows according to these figures. So despite we are consuming most of the footwear, we are not producing it. In Portugal, fortunately, we have been able in the same decades to grow. And we believe this is due to the bet that we have been doing. So since that time, we bet in quality, differentiation, added value, so not mass production, not fast fashion products, but products with quality that are differentiated. And the products are sold to the second high value in the world. So after Italy, Portugal is producing the more expensive, valorized and differentiated footwear. One of our important assets is to have a complete cluster. So we produce all the materials needed to assemble footwear and leather goods, and also soft tech and production. But now we are in a changing moment. I will not talk about military targets because we also have this, defense and so on, but we are in this context of industrial symbiosis, so talking about what are our objectives in terms of going for the future, being bio, so more renewable, circular, durable, digital and resilient. And to do this, we do believe in industrial symbiosis. What we are doing are already industrial symbiosis within our cluster, but also with other industries, textile, automotive, rubber, plastic industries. But also, because we need to move away from the intensive use of non-renewable resources, we are betting in use agro-food industry wastes, not competing with animal or human, of course, feeding, using only materials that have no other uses, even they have no uses in cosmetic. And you see here some examples of the industries or the sectors we have been making industrial symbiosis. Now I will explain what are our sets. So footwear being at the bio, renewable, circular, sustainable economy that has lower environmental impact, materials that are based in local knowledge and resources, and production technologies that are developed in Portugal or elsewhere, but are advanced, digital, and eco-efficient. To reach these targets, we are deploying several projects. One is BioShoes for All, that intervenes in the area of materials, footwear, circular economy, but also digitalization, capacitation, and dissemination. We are a big consortium, the biggest ever project we have in the footwear cluster in Portugal, and I believe that even at European level there are very few projects with this dimension in terms of number of partners, investment, and results expected. I will present some of the work done. First, regarding the industrial symbiosis at the level of biomaterials, charges, and fibers, we identify a set of big set. We studied 22 materials, including the ones that you see here. We try to see if they could be used directly or what kind of physical chemical preparation they need, even to extract some chemicals that are relevant, and if they are in quantities necessary to produce our products and with sustainable, let's say, value chain. And in this moment, we identify that some of them have not the value chain needed, so we will work in the future with that and invite you also to this work and to collaborate with us, and I'm completely open to collaborate with all of you in this field too. Some of the results, for example, having bio leather that are tanned with pine tree bark, coffee grounds, or lovely trees. We develop new tanning process that, in addition to this, have use less water, up to 20% less water, and also are able to cycle the production waste of leather themselves, and resulting in bio leathers that are really adequate for our industry and have high quality. But in parallel, we are developing also innovative textiles that can have up to 70% bio-based content and include, for example, olive stone charges and biopolymers. We are developing bioadhesives. These are not ready for the market, so the leather and the coated textiles are ready. We are launching them. Also studying new biopolymers for the soles like BioTPU. In fact, we are launching to the market already soles based in bio rubber biopolymers up to 9% bio, and corking soles with, for example, including the cork, but also leather waste, and for example, tomato, pear, apple. And we are not using these biochars per se. We are using them in all the cases to functionalize, and in this case to increase the moisture absorption. With all of this, we design new products in order to reduce really and definitively measuring the environmental footprint. This is one of our work and expertise at CTCP, is calculating the footprints and tune the development and production of the products in order to decrease them, as you see in this example. In this particular project, you see here the number of products, 25, 24, 15, and 23, that we have been able to deploy and reducing the several of the impacts. Regarding circular economy, we will focus now in this presentation in two types of waste, industrial waste and symbiosis that we are doing. Again, in this case, we develop coated textiles with high content in the recycled material. They are not the coated textiles at the end are not easily recycled, but in their composition, they have high quantity of recycled content. We will study in a future project how to cycle these coated textiles because there are several layers and it's complex. We have been able already to, in the terms of polymers, that this is one of the areas of expertise at CTCP, is not only compounding virgin materials like thermoplastic rubber, thermoplastic polyurethane or PVC, but cycle the materials with additives in sometimes nano additives or whatever. Regarding rubber and polyurethane and EVA, the content of recycled material is less than in the other cases, but we are to work on that in the future. In all the cases, of course, we try to functionalize. In this particular example, you see the green bars, the dark green bars. This is rubber that has been composed with fiber resulting from footwear production, namely leather, and you see the increase in tear strain. This is an important result for rubber, for soles, and other applications. Also doing industrial symbiosis with producers in other industries. For example, this boot is made with Finnish fishing wetsuits. We have other examples in which we use diving and surfing suits, and we have a PVC boot that high content of material coming from this industrial symbiosis. Regarding post-consumer footwear, here I should say we are giving the first steps. A lot of research is needed, and I hope that we can collaborate with some of you in the future in a project that we would appreciate to collaborate. We are now able to, for example, cycle well PVC and some polymeric footwear, so all polymer footwear, but the other type of products need some research. This is an image of tests that we are conducting, but this is lab scale in order to separate footwear complex products and able to cycle them. Of course, we are working at the design phase of footwear in order to discomplex, let's say, the footwear, but we need safe, we need protection, we need durability, and this is a compromise that is complex.
Sorry, Maria Jose, 1 more minute for conclude, please.
Okay, thank you. Of the project, I will not focus a lot on this, is also working with digitalization. Here, for example, a traceability tool, equipments that we invest based in supercritical foaming to have thermoplastic materials that are recyclable at the end of the life. That is not the case in the past. These are the 2 first technologies of this kind in Europe, and the results in terms of the decrease of footprint of the products. Also preparing and developing technology in Portugal. Regarding CTCP, we are a non-profit organization, more than 70 persons. These are a number of partners, our area of work, and that's all. Thank you so much.
Thank you so much, Maria Jose, for your presentation. You are doing so much work with the social industry. Congratulations. And I'm sure that probably through our LIAISE action, you could find partners to work on this post-consumer footwear recyclability.
Thank you.
I think that there are some questions. There is one question for you, Maria Jose. What are the similarities and difference between industrial part and cluster? Can the same principle be applied in both cases? Where it's easier to apply industrial symbiosis and circular economy? 3 questions in one. You are mute.
Yes, can you repeat, please?
Yeah, I'm going to go for the first question. What are the similarities and difference between industrial parks and clusters?
Well, in our case, when we mention cluster, it's because we are having companies from all the areas needed to produce this product. For example, we have companies that produce footwear and leather goods, but also the ones that produce the materials, the leathers, the polymers, the technologies to prepare them. I'm sorry for my voice because I was quite, you know this, and also research partners, some of associations. So this is a cluster that is making a strategy. So one of our assets is that we have annual plans for almost 30 years that we have strategic plans, including all the cluster. To prepare these strategic plans, we hear all the parts. And so this is the cluster. This is what we mention as a cluster. Industrial collaborations may be bilateral or whatever, but in our case, have this broad field.
Okay. And he's also asking, where is easier to apply industrial symbiosis and circular economy? In industrial park or in cluster? Or
In both.
but
Yeah.
the same principle could be applied for both cases.
I think so. Thank you.
Thank you. And there is another question also for you, Maria Jose, is which impact categories were addressed in the traceability and logistic footprint?
Regarding the footprint, we are using the product environment footprint methodology. In this methodology, we analyze 16 impact categories, 16. I select some of the categories that I think are more relevant for this case, because when we are doing this project and moving this transition, one of our objectives is to reduce the fossil content. So that's why I show that footprint, the carbon footprint also, so climate change indicator. And we calculate like this. We have been involved in the development of this methodology for almost, I think, 12 to 15 years. Now it's going to another level, to a level of eventually being officially adopted by the Commission in the coming years, but this will not happen, let's say, in a couple of years. In any case, we are using this methodology because we believe that since it is well defined how the calculation should be done, comparing to other life cycle analysis. And I invite you all to if you are interested in, we can collaborate with you on this. Thank you.
Thank you so much, Maria Jose.
Thank you.
I think there is no more question for the audience, and also as we are out of time, I would like just to thank you again to you, Maria Jose, Snezana, Carlo, and Yasmin, for your interesting presentation. As always, this is being recorded, and also we will share the presentation with all of you, so you have their contact, their information, and all the details. So any kind of synergies are more than welcome to them. So just contact them for any kind of question or for any kind of conversation that you want to initiate. So once again, thank you to all of you, also to all the audience to be here, and I wish you a happy and relaxing weekend. Thank you so much.
Thank you so much. All the best. Bye-bye.